Hey you guys, what's up? And today I'm redoing my presentation today for Mr. Kuhn. So today it's going to be about section 4.1.2 ocean water properties, and it's made by me. Alright, so let me go to the next one, and it's going to be about what's inside the ocean. So for the first bullet point, I'm going to be talking about how ocean waters are salty and contain minerals and dissolved gases. They also have a high heat capacity and vary in density depending on its temperature and salinity. So basically what this is talking about is like the components inside the ocean and stuff like that. So like how much like salt and other things are inside. So for the next one, I'm going to explain what salinity is. So salinity is the amount of dissolved salt in a given quantity of liquid. So this is just the amount of like salt inside of like a liquid. So like the ocean is filled with a lot of salt. So that's kind of what salinity is. So if I'm gonna go to the third bullet point now, and it's gonna be about ocean water in drier, hotter climates usually have more salt compared to ocean water in humid, cooler climates. So basically, what this is talking about is like, let's say you have a super cold ocean. So none of the heat from the sun is going to come down and like heat up the components inside the ocean. So it's not going to create any salt and stuff like that. So, but if it was hotter, then that's when it's going to create more salinity and stuff like that. So if I go to the fourth bullet point, I'm going to be talking about how less fresh water runs into the ocean and more water evaporates in drier climates. So what this is talking about is how more of like the everything from the ocean is evaporating, so more of that like fresh water that's coming in is evaporating, and that's what's happening here. So the fifth bullet point, I'm going to be talking about how places where large rivers drain into the ocean usually have low salinity because such rivers and large amounts of fresh water to the ocean. So what this is talking about, like what it's talking about how more like bigger places like the oceans and stuff like that, it's gonna have like let's say like a large source of water, and that water is gonna come down and provide some stuff to the ocean, and that's where you're getting all the components and stuff like that. So if I go to the next slide, I'm going to be talking about the density of water in the ocean. So for the first bullet point, it's talking about how water is more dense when it is cold or salty. More dense water sinks, forcing warmer or less salty water to the surface. So what this is talking about is So this is talking about how like if I have water, right, and I put salt in it, so that salt is going to create more density around the water, and that's where it's going to take up more space. So that's what that's talking about. And if it has less salt in it, it's going to have more components because it has more room to put stuff in it. Okay? So for the second one, it's going to be talking about, I can't really say it right, but thermohaline is the currents that move nutrients and gases throughout the oceans. So as we know, the ocean has a bunch of currents, and those currents are pushing a bunch of stuff. And I'm going to be getting to this in a little bit, but it's providing something to other, like let's say animals and planktons and stuff like that. So those things are eating off of this. So, and the third bullet point is going to be talking about how such areas as the Weddell Sea and Antarctica produce the densest water of the oceans. This water, known as the Antarctic bottom water, sinks to the deepest depths of the ocean. So these are like the deepest points in the world, like water wise. So those places are going to be like the deepest and stuff like that. So like for example, there's one place in the ocean where if you flip like Mount Everest over, it's like that deep. It goes like all the way down to like the tip of Mount Everest. So that's how deep it could get in those places. So if I go to the next one, I'm going to be talking about the gases inside the ocean. So ocean water with low salinity can hold more gases than saltier water. So with like as I said earlier, like if I have the cup and I put salt in it, it's gonna have less room because that salt is taking up more space. So the ocean water without any salt, with salt, is gonna take up more room. So it's gonna have less room for the gases and stuff like that. So if I go to the second PowerPoint, second bullet point, I'm gonna be talking about the three of the most abundant types of gases. So the three of the most important types of gases, abundant types of gases are carbon dioxide, nitrogen, and oxygen. So these are like the chemical components that are inside the ocean, and I'll get to more of that. So carbon dioxide and nitrogen are important for one-celled plants called phytoplankton, which are the foundations of food chains, ocean food chains. So, as I said a little bit earlier ago, I talked about how like the currents are feeding off, are pushing, they're pushing, and certain things are feeding off of this stuff. So that's kind of what's happening here, is that carbon dioxide and nitrogen, the phytoplankton is feeding off of that stuff. Okay. So, and the fourth one, I'm going to be talking about how even though so many solids and gases are I can't say it, but are inside the ocean water is still very clear. Okay, so let me explain this more. So let's say we have like a cup again. Let's get the cup again. So I put that salt inside the cup again, and we have the sunlight, and it's gonna go through. Let's say it's a clear cup, and the sun is gonna kind of go through that clear cup because there's still spaces in which the sunlight can travel through. So I'm gonna be getting to that in a little bit more. So okay, so yeah. So how sunlight affects the ocean, okay? So for the first bullet point, I'm going to be talking about how the sun actively warms up the top 1 millimeter or mile of ocean, mile of ocean water, and the wave action distributes the warmth to a depth of about 100 miles, okay? So the sun, it's really big, right? And there's a lot of rays coming down from the sun. So when those sun rays hit the ocean, it's gonna penetrate all the way down, but at a certain point it's not gonna reach all the way down because my phone just moved. But the sun can't travel that far. So the sun rays can't travel that far. So that's what it's talking about there. So for the second bullet point, it's talking about how this means that at any given location, the water's temperature is fairly consistent through the top 100 miles. So the temperature is basically going to be the same throughout those 100 miles because it's getting the same amount of sunlight as 1 mile in 100 miles. So that's what's happening there. So the 3 important zones in the ocean are the euphotic, dysphotic, and aphotic. So the top layer is going to be the euphotic. It's going to be the top kind of 1 mile and stuff like that. So that's the top layer. And the second layer is going to be the dysphotic, and that's the middle layer, the deepest layer. And the deepest it goes is the aphotic layer. And that's where the sun kind of hits the bottom of it and stuff like that. So let me show you guys kind of a picture of what that looks like. So inside the book, it has a picture of what that looks like. So right here is gonna it shows the picture of the different types of stuff. So as you see here, the first layer is the euphotic zone, and this is the first layer. Second layer here, disophotic zone. Third layer, aphotic zone, and then it just goes deeper, deeper, deeper until you hit the bottom of that. So that's what's happening there. And if I talk about the fourth one, as you get lower and lower, the sunlight is not as much because it does not travel that far. So that's basically what I said earlier about how the light rays cannot reach the bottom. Okay, so let me go to the next slide. And this is the organisms in the ocean. So phytoplankton are the atrophic components of the plankton community and a key part of ocean, seas, and freshwater basin ecosystems. So if we didn't have all these plankton and stuff like that, they contribute a lot to the ocean and stuff like that. So that's why these are important components inside the ocean and stuff like that. And so for the next one, I'm going to be talking about how phytoplankton die. When they die, they sink to the bottom of the ocean where bacteria decompose them and release their nitrogen back into the water. So this is why they're important, because when they die, they give those kind of biodegradable things that the ocean uses and transports to other things so that other things can use that components to use and live. So for the third one, I'm going to be talking about how currents bring this nutrient-rich water back to the surface for the cycle to begin again. So let me explain the cycle. So the phytoplankton lives, right? And then it has its living period, then it dies. So when it dies, it disintegrates and decomposes, and the cycle just keeps going over again. And when it dies, when it dies, it's passing those nutrients on to something else. So that's what's happening there. Okay, and that's kind of it. Yeah, that's my presentation for 4.2.1, and I hope you guys enjoyed it, and maybe I'll make more videos like that like this if I'm bored. So I don't know. I hope you guys enjoyed it.